In question number 4, it's a rates question and a context of a cone. Now, be careful with your cones because we can use similar triangles with our cones. So if I have an inverted cone and it's full of water, then the water takes the shape of a cone. If it only has part water in it, this also takes the shape of a cone, and these cones are similar. So I can use the idea of similar triangles. So if I was to consider the triangles, this is the radius and height of the water, whereas this is the radius and height of the full cone. In this particular case, 5 and 15. Okay, so we have a conical tank, radius 5, depth of 15, and it's full of water. So the volume is going to be 1/3 pi r squared, 5 squared times h, which is 15, and that gives me 125 pi cubic meters. The container trucks below, it leaves at minus pi cubic meters per minute. So if I have the volume and I divide it by the rate, that's going to give me the time, because I will have meters cubed divided by meters cubed per minute, which is meters cubed times minute on meters cubed. So 125 pi divided by pi, 125 minutes. Part C then gets expressed the volume of liquid in the tank in terms of R. So if I've got my tank and I have this amount of liquid in it, the volume is going to be 1/3 pi r squared h. I don't know what r is and I don't know what h is, but what I do know, because of similar triangles, that r over h is 5 over 15, which means that r equals h divided by 3, or h equals 3r. So now I can replace my h with 3r, and I've got volume equals 1/3 pi r squared times 3r. The 3's cancel, and I left with the volume equals pi r cubed. And now the question's asking about a change of rate. What is the rate at which the radius of the liquid is changing? So dr dt will be the chain of derivatives dr and dt and dv and dv. Now I know that it's losing pi cubic meters per minute, so that's minus pi. And from this, dv dr is 3 pi r squared. Therefore, dr dv is 1 on 3 pi r squared. So that gives me dr dt equals minus 1 on 3 pi r. Sorry, 3r squared.